And first of all, we got an amazing speaker right now, and I'll introduce him as soon as I open up my notes. So we got dapplion coming up. So dapplion, and yes, that is his name, or rather his pseudonym that he prefers to go by, is the epitome of work hard, play harder. He is team lead on ChainSafe's Lodestar implementation team, and for those not in the know, Lodestar is ChainSafe's TypeScript implementation team. They are the 5th client in production on Ethereum's proof-of-stake mainnet, and recently celebrated their first block produced on mainnet. Congratulations. On the note of work hard, play harder, dapplion is a prolific coder and thinker. He loves to dissect every problem, every scenario, and reflects deeply on outcomes. More than that, after hours, he is a passionate liver of life, and he's always goading on his fellow chainsafers to be hitting up the next club. So without further ado, I'd like to bring dapplion up onto the stage. His talk is titled Realizing the Light Client Dream in Ethereum. dapplion?
Hey, hello everyone.
What's up, dapplion? Yeah, we can hear you.
Hey man, thanks for the intro. Did you wrote that?
I did write that.
I didn't wrote anything. I was asked to do it, and I said, "Nah, fuck that shit."
Well, I'm glad I wrote one for you, and hopefully it served its purpose in introducing you. So I'll let you take it away, and then yeah, looking forward to your talk.
Thank you. Okay, I'm gonna share these. Can you see it all right? Yeah, awesome. Well, hello everyone. Thank you so much for coming. I'm really excited. I'm gonna share today how we at Lodestar are realizing the light client dream in consensus layer. So, as Tim said, I'm dapplion from the Lodestar team at ChainSafe, and I would like to start today explaining how do we interact with Ethereum today. Today we have this conundrum where we either have to spend a bunch of resources and time syncing Geth or fully trusting in Fura. And I want to say kudos to Geth, because just 2 days, I mean, it's such a crazy achievement, but still, it's a hard choice between 2 very different extremes. And what's causing this? Why do we only have these 2 options? And in my opinion, it's because currently Ethereum nodes are not able to produce trust in a scalable way. So if you are not able to trust a node, you can either run your own and trust it, or trust someone else's, such as in Fura. So Piper did this great talk at SCC explaining this problem in depth. He's tackling the Portal network, which we will touch it later. But he brought up this point that we should have this purple unicorn, this middle ground between these 2 extremes, to offer the community a different option to interact with Ethereum, with a different set of trade-offs. Because we don't really know what's the interest. There can be a massive amount of users that are willing to take a different trade-off to interact with Ethereum, and we must provide this alternative. So you could say, okay, what about LES, the Light Ethereum protocol, or what have existed as light clients until now? And they have never really worked because some reasons. They have always been a parasitic participant of the network, which got relegated into never getting supported, then under a flag, and eventually it's really hard to find someone that can serve the data you need. And because there is no incentive, it essentially died out for a lack of scale. So I want to remind first why we are doing this, why are light clients so important. And first I got these 2 quotes that are not great. I mean, we know Ethereum, decentralization, yada, yada, but why? Why is this important? So earlier this year, Elon Musk did this tweet. It's not great. He essentially says we could increase the block time, decrease, make the blocks faster and bigger, and we solve the fee problem. And Vitalik wrote this excellent post, The Limits of Blockchain Scalability, which explains why this is a very, very bad idea and what could happen. And he brings this case where if you make the nodes so hard to run, no one will run it except a few cartel of people that are very invested and very interested in the blockchain. So you would have a huge centralization of power among a few individuals that could coordinate and corrupt into doing something like, surprise, one transaction with 1 million tokens to a web address. Then 50% of the network accepts that, and then the funds get dispersed into DeFi, and you have a huge issue because the community reacts too late, and it's probably nothing else to do. I mean, I want to remind everyone that's Aziz on Ethereum that the DAO accident, we were really, really lucky that the hacks fund went into a single place and were locked there for a large amount of days, I think about a month. And that's what allowed us to do the fork. But if that was not the case, if the funds had been dispersed through the whole protocol, it would have been really hard to undo the damage. So in Ethereum, as Hasu put it perfectly, the only way to defend against protocol attacks is by having a culture of people with running nodes. It doesn't matter if we are proof of work, proof of stake. So like clients achieve this goal by making the barrier of entry lower for some people if they want to run a different type of node. So yeah, don't trust, verify, and that applies to the whole stack. So the wallet, the front end, the RPC connections, smart contracts, and a whole lot of initiatives to achieve this goal. And we are working on the infrastructure side. So yeah, we need like clients, that's very clear, but what's new in proof of stake? So in proof of work, if you want to track the head, if you want to know what's the head and then get the data, you just have to get headers, compute the proof of work, and see what is the longest, and you're done. However, now with proof of stake, things get very much complicated. You need to track all the votes from all the participants on the network and run the LND ghost algorithm, and that's essentially what a full node is doing. So it's not light. This is why recently the Altair fork has enabled sync committees, and this is a new primitive that allows to track a much smaller set of participants, and you can essentially come to the conclusion of what's the head at a lower crypto economic security, but still good enough. So to give you numbers, the sync committee size is 512 validators, and it rotates about 27 hours, roughly 1 day. It's big enough such that it will be very hard to be corrupted. And given that the currently mainnet is about 250,000 validators and growing, the chance that you could corrupt these 512 that has been randomly selected is very low. And because of these numbers, you can make simple math and come to the conclusion that it will take about 25 kilobytes per day of data just to be synced. So this is really, really, really like fucking awesome. So how does this work? As I said, the sync committee gets randomly selected from the validator pool via on-chain randomness. And the duty that they have is whatever they believe is the head, they have to sign, attest to that, and then distribute the signatures through Gossip. There are other participants that do aggregation, and it eventually ends up in a block that it's used to reward them for this service. So a light client then can use this information in order to sync to the current period. And in this chart, what I'm showing is that the sync committees are sequential. And the way to advance is going from the sync committee that you trust, the one that is labeled as active, and then gathering a signature that attests who is the next one. So you can jump from committee 1, signs committee 2, signs committee 3, signs committee 4, up to the head, and then you can track the head. So to show you an example of then how this would look in practice, here I'm showing this diagram of trust. I think it's very important when you visualize this that you come from something that you trust and you want to gather new information. So here we will start from this entity that I call the sync aggregate, which is what the sync committee signs every block. With that, you can get a block header and verify the signature, and this block header contains a root, which you can get a Merkle proof up to a finalized header, and from that header, the state that includes the next sync committee. And this way, not only you have something that's attested by a sync committee that you trust, but with finality, you are safe against reorgs. And this is what we used to think. I also added these pieces of code that are from the spec that we use in Consensus. And everyone that's curious about the protocol, I would highly, highly encourage you to check it out. The specs are beautiful and super easy to follow and understand, and it's a great way to get a bit more hands-on with the protocol. So yeah, go check it out. I think it's Ethereum/Consensus specs. So with the previous protocol, you can sync from the sync committee that you started. Could be Genesis, a RxGTT sync, or the previous time that you open your wallet. Then you sync to the latest one, and now you can track the head. So Vitalik presented this very simple but effective protocol to track the head, where you essentially gather these headers that come signed from the sync committee. And since they are not reorg safe, what you would do is trust a super majority of the nodes. So you can observe what's the average participation through a period, and then say whatever has more than a factor, in this case, for example, half, is something I would trust, and that would become the head if the slot is higher. And we have tested this, and it actually works really great. Thanks to some optimizations in current mainnet, participation is really, really high, between 99 and 100%. So this would work really well. In case there was a failure or an attack on the network, as you can see here, by this drop in participation, the live client would lose liveness, but in order for it to be tricked, someone would have to corrupt at least half of the participants. And with the current randomness, that would be really, really unlikely. So what has Lodestar built with all of this? So we are really proud to contribute to the public's goods that will build this new era in Ethereum Consensus. And we have done libraries for BLS, serialization, and other tooling. Specifically for this demo, we will see BLS. Just to give a brief introduction to people that are not aware with it, is this scaling magic crypto thing that allows Ethereum to have a validator count as high as it has now. As a reminder, before BLS was the thing, the minimum staking requirement for proof of stake was 1,000 ETH. So if people are complaining now about 32, just remind them and thank them about BLS. The other great piece of tech that we have built is the SSZ. It's a really good, really well thought out encoding library that replaces RLP, and it gives you binary trees and other goodies that makes things for live client really efficient. And then at least Lodestar and Teku are using tree structural sharing, which allows to keep a huge number of states in memory. And that's really important if you want to serve arbitrary proofs to anyone that would request at different points in time. So our other contribution has been to develop a server like client based, which is sensorable but trustless. This is what we'll demo later. And this is a proposal that we have recently opened a PR. We hope to standardize this. There is already community support, at least for Prism and Nimbus, but we would really love for every implementer to adopt this, and hopefully we can have wide support for consensus-like clients in every node. So to give you a brief example of how this would work, you first have to gather some sort of trust from, for example, Genesis or RxGTT, and you get this block root that you trust. You say whatever state is referenced in this block root, I think it's correct. Then you can hit this route, the live client snapshot, and you would get the first in committee that you trust. Then you compute where am I, what's my period, and what's the sync period currently being attested, the clock period, and then you can request a range at live client /sync committee updates. And you could hop, like we said before, from sync committee 1 to sync committee 2 to sync committee 3 to sync committee 4 to the current clock. Then you can subscribe to here. SSE stands for server sent events. And this is a unilateral protocol for the server to push events. And here the server would send header updates to the client. And since you have the correct sync committee, you can just validate the signature and apply the head rules that I explained before and track the head. And now that you have the head, you have a state root that you can start requesting proofs against. And here you would hit the live client /proof. at the state root we have, and you can then request fun stuff. You can get the execution layer data, you can get balances, you can get sharding data, whatever we want, and then you transition to user land. So demo time. Hope that the demo gods are friendly with me today. Let me, here. So this is a very simple proof of technical concept of how all of this technology works in the browser. It comes together. So to start with, I said before, we need this trusted checkpoint. Here to simulate that, I'm gonna go to Beacon Chat and pick a random epoch. I trust these guys. I think this data is legit. If you don't, you could just go to a friend or somewhere else and get any trusted checkpoint from other places. There is a whole project to do this in a very UX-friendly way, but it will come, but not yet. So here, a checkpoint would be the first block in the epoch. Gather that, put it here, and when I click this button, I would request a snapshot that validates against this root. This already happened. I have validated the snapshot, and now you can see that the last sync period is 32, and the current clock period is 32. So this line client has already subscribed to the events, and I'm getting heads. Right now, I'm subscribed. I have a head at this slot with this root. We can check it's almost at the clock. There's a small delay. And then here I can ask what paths of the state I want to request. And here you can see the result. So just an example, I'm getting the latest block header body root and the slot. Just to complete this, this is our validator that has been proposing blocks. We did 2 actually, so yay. And I'm going to check the balance of this validator. Let's copy the index and put it here. I want to know the balances of this one. And there you go, 34.4 ETH, which matches this one. And there you go. We have a trustless sort of block explorer. And just as a show of how this thing looks, this is all the data that's attached with the proof. And this is used to compute the root eventually and make sure that the data validates against what we have. And this is why this will come with extra overhead. And I think we have a duty to educate users to understand that these extra kilobytes in exchange for having the ability to verify all the data you consume on chain is very, very valuable. So continuing, what we have seen so far has been a consensus-like client. Essentially, coming to consensus means knowing what is the tip of the head, but we haven't been yet in any of the fun stuff, say the user land. So here is where I want to make people understand this idea of the stack. On the layer, you have the light client that we have shown you today, where you come to a head with the help of the sync committees and the sync aggregates and all this fun stuff. Then you can use state proofs to get to shard state root or layer 1 state root. And then with other primitives like the LAS protocol or the Altair network, you can then against the state root request specific data on a contract and then run the VM locally in order to get data. This is a project that we are working on right now, but this would allow you to have a trustless MetaMask. And on the other hand, once we have sharding, you can then get these roots up to some shard root and then go to some other protocol. This is not specified yet, but hopefully something in the lines as the other proposals in order to get data and consume roll-up data in a trustless way. So yeah, this is what I'm really enthusiastic about. The status quo, the wallets that we use are not trustless, are censorable. It's very legacy, it's very Web 2. And I think we can do better. So with this technology, we could have a trustless wallet that would still be censorable. But just getting to this point of being trustless, I think is a huge step forward, worth trying. And then there are other initiatives and really bright people working on the censorable part to get rid of this, especially the Altair network. I think this is what have the most chance of success. But yeah, really exciting stuff. And at least in my opinion, I think the trade-off is worth it. But we will do educate and promote for sure. So yeah, what's next? First, we want to integrate with L1. The merge is coming. So excited. So if we can nail this, and we are collaborating with the Ethereum.js team and other stakeholders in the space to do this proof of concepts, get the light clients in Ethereum, execution layer, Polystap, and hopefully build a trustless wallet when this lands. Then we will work on the sensible part. So experiment with networking on the browser. There are already some proof of concepts of getting around the problems that the P2P is a bit tough to do in the browser. And last, since we're going to this rollup wall, we will start studying how can this be integrated with optimism, how things would look. But yeah, really exciting. So if this is cool to you, please join us. Lodestar is hiring. We have tons of cool stuff ahead. So we would love to have you. Reach us out. And yeah, super proud to say we are not only doing like clients, we already have a productionized Beacon client that it's doing its job in mainnet, it's doing blogs. So yeah, thank you to everyone that has contributed to this. So cool. Thank you everyone for your attention.
Awesome, amazing, dapplion. That was a masterful shill at the end about the Lodestar hiring. I love it when ChainSafe speakers are able to do that. And yeah, I definitely think we're all in with Lodestar, right? Like we're not like half a foot in the door or anything. We're all in. We're all in with Lodestar. So thank you again for your talk. That was amazing. We have some questions from the audience. Would you like to take them? Okay. I can read it out to you. Just so we can get it for the YouTube video after too. But first question from Anonymous. They're all anonymous. How far are we from in-browser like clients? How far are we from in-browser like clients? And how far are we from relying so much on Infura?
So if we say consensus like clients, I already showed you a demo. It's working. It depends on your trade-off. So if you are okay with talking to a server that's trustless, I think this is doable today. The execution part is a bit more tricky because you have to run the EVM on the browser, but it's also doable. We are talking with the Ethereum.js people to make this a reality. But then also we are speaking with the Ethereum Foundation. Even Vitalik is really enthusiastic about just relying on a server, and maybe n servers, let's say 5, it's way better than what we have, which is 1 and fully trustless. So if you're okay with not having P2P, I think it's close, to be honest.
And I guess like in terms of like timelines, maybe, I know like as developers, it's never good to commit to timelines, but like how far are we away from in-browser clients? Like your best estimate?
Yeah, I think a year is a realistic timeline.
Ooh, that's a good hot take. Excited. Okay, next question. Do you think light clients will become a default way of interacting with Ethereum for most of the users in the future?
I hope. I mean, the key part and philosophy of blockchains is that people have the choice to choose what they want. I mean, the fact that blockchain is working, it means that people value decentralization over other things, but centralization will always be cheaper and will always be easier. But if this tech is available and it's not that annoying, and it kind of makes sense, and the UX is good and it's not too expensive, if people do understand the trade-offs and value decentralization, then yeah, hopefully they will adopt it. That would be awesome.
That's right. Thank you for that answer. And definitely, it's a big educational component too, I think, right? Like I would think. But okay, next question, also from Anonymous. What dev tooling would be required to replace the inferior RPC connection in a dApp with a light client?
What tooling? Yeah, I think when we go to execution layer, we will partner with the Portal network, and they are doing a great job already on answering these questions. So yeah, there will be a bunch of networks and stuff that I think from the point of view of a developer, you will just import a library and it will just work. At most, you will have a greater ping. So if you're expected now you just to do a contra call, it takes 150 milliseconds. Maybe now it will take 1 second. But I think it will be as easy as it is now to integrate and use.
Thank you for that. And then here we have another question. Is there anybody researching how to create incentives to serve light client data? How do you get involved with this research?
Yeah, I know there has been research in the past, because light clients are not a new idea, especially in execution land. This is why I think if we want to go fully decentralized, fully peer-to-peer, it's going to be tough. Like the incentive problem is really, really hard. If you want to be involved, join us. If you have a good idea, I think even the Ethereum Foundation will be interested in funding it because it's a huge problem. But I'm personally not going to go there yet. I'm going to work more on the server-based model. But yeah, once this is possible, that would be huge. That's kind of the end goal eventually.
Fair enough. Thank you for that. And then last question from the Q&A. What is the sync period and clock sync period you demoed on the webpage?
Yeah, so in proof of stake, time is really important. It's what regulates almost everything. So we have a slot, which is what would call now a block time. That it's not a block because it may have a block or not. So it's a measure of 12 seconds. Then if you put 32 of these together, you have an epoch. And then if you put 256 of these epochs, you have a period. So it's just a made up idea to compartmentalize things. Because yeah, instead of calling them n seconds, if calling it this way, it makes things easier to reason about. So yeah, one sync period is 256 epochs, which is 32 slots, which is 12 seconds.
Wow, so everything happens like really fast on Ethereum proof of stake. Like, cool. Okay, I think that's it for our questions. dapplion, thank you again for your time. Are you in Barcelona right now?
Yeah.
Nice. Back home. Yeah, thank you for stopping by. Thank you for presenting. Love hearing about the progress for Lodestar, and I'm sure there's a lot of exciting things coming up for your team next year. So thank you, and I'll catch you around. And feel free to stick around if you've got nothing to do and you want to listen to some more cool talks. We got some dope ones coming up.
Yeah, for sure. Thank you for hosting me. It's been a pleasure. See you all soon.
Okay, bye.